Okay, greetings. I decided to go ahead and give you, well, I didn't, I was going to do it anyway, but I assigned you like 9 problems that are kind of tricky. And instead of, uh, we need to move on. We need to go on to energy and things like I wanted to get to energy and maybe even momentum by the time the next exam came up. Then we'd be in good position for the rest of the semester. But anyway, but it's not about how much material you cover; it's what you uncover. You know, it's how and so. I'm going to do like 4 or 5 of these problems and just like little 4 or 5 minute vignettes. And I'm not going to do the go problem because it kind of shows you how to do it. But I wanted to start with this elevator problem because this is really cool, and this really kind of shows you how when you draw the forces, when you look at the free body diagram, look at the forces, how it just spills out. Something that might be counterintuitive just spills out. So without further ado, I'll get me out of the corner here, and we'll do this first little problem here. It says a 77 kilogram person stands on a scale in an elevator. Okay. And oh, good, I got the outlook turned off, so that's good. And what is the apparent weight when the elevator is accelerating upward, moving upward at a constant speed, and accelerating downward with an acceleration of 1.17 meters per second squared? Okay, so we've got this apparent weight. Now here's the deal. So let's 77 kilogram. I'm going to put in the accelerations up. Mass 77.9 kilograms. I've got to get all the stuff put in. Acceleration up is equal to 2.25 meters per second squared. Acceleration down would be negative 1.17 meters per second squared. All right, so now let's take a look at this. I think one thing that might help with these things too is if I did this. I got a call from a student in my one of my complete online class, and he's an older gentleman, and he said he couldn't see what the heck I was doing on these things, and so I wanted to make so now it's a little bit bigger. All right, so here's the deal. All right, so you got somebody in an elevator, okay? So they're standing here in the elevator, and they're standing on a scale in the elevator, and the scale, what the scale does is give you the normal force. When you step on a scale, like when I step on a scale and it says so many gazillion pounds, that's the normal force pushing up on me. All right. So here's the thing: what would that scale read if somebody cut the cable? Ah. So let's just look at the cut the cable. You'd be in free fall. And the scale would read 0. In other words, you'd be weightless. All right? And here's why. Sum of the forces in the y direction, all right, is equal to, all right, so you're here. Somebody cuts the cable. There's nothing pulling you up. There's nothing holding you down. Somebody cuts the cable. You are in free fall. Okay? So you're standing on this thing. You've got a normal force going up, so that's what we want to compute. You've got your acceleration downward is negative 9.8 meters per second squared. All right, so the sum of the force, so this is your overall acceleration. So the sum of your forces is equal to negative m times 9.8 meters per second squared is equal to the normal force plus what's the force pushing up on you? That's it. That's the only thing. So there you go. You're in free fall. You are accelerating downward. All right, now let's look at the elevator. Now let's look at this problem real quick. Let me help you set this up. All right, so you got a person standing on a scale on an elevator. All right, they're accelerating up. Acceleration in the positive direction. All right, so this is what they're accelerating upward. So the sum of the forces in the y direction is equal to the mass of the person times acceleration up, which is equal to, now let's look at the forces. Gravity's pulling them down while they're standing on the scale, and they've got a normal force here. Okay? Okay, well then we go Fn minus mg, and what you're trying to solve for is the normal force. Okay? So that's going to be a big normal force. So that's going to be bigger than g. All right? And if you've ever been on an elevator, once it starts to go up, you notice your knees buckle a little bit. That's because you're getting a little bit more force. All right? And then you repeat the same thing for going down. Except this time, which way is the acceleration going? Right, negative. Okay, so we'll stop on this problem. We'll do about